Hi class, this is Norman Stevens. I want to review the chapter checkpoint in chapter 5, which is on page 134, and go over the concept of the GDP. I'll go over the questions and the answers for this checkpoint, and if you have further questions, please let me know. Question 1 reads as follows. Figure 5.1 shows the flows of income and expenditure in an economy. In 2009, U was 2 trillion, V was 1.5 trillion, W was 7 trillion, X was 1.5 trillion, and Z was 0. Calculate total income, net taxes, and GDP. The first part of this, calculate the total income. Well, the total income is flow Q, and that equals total expenditure, the sum of consumption expenditure, investment, government expenditure on goods and services, and net exports of goods and services. The formula used to calculate the total income is the GDP formula using the expenditure approach, and that's Y equals C plus I plus G plus NX. You might wonder why the letters changed. Well, they're changed in this question so that a person can think about the flow in algebraic terms and demonstrate a comprehension of the flow. So the letters aren't simply given, you've got to substitute the correct letters for what's given. And you switch the letters then. So flow U is government expenditure on goods and services. That's G. Flow W is the consumption expenditure. That's C. Flow X is the investment, which is I. And flow Z is the net exports of goods and services. That's NX. Then you plug in those values into the standard formula. And the numbers you'll get then is that total expenditure equals 7 trillion plus 1.5 trillion plus 2 trillion plus 0, and that equals 10.5 trillion. The total income, and that equals total expenditure, equals 1.5 trillion. For 1b, to calculate the net taxes, the formula is given on the bottom of page 114. The formula is Y equals C plus S, plus NT, or the total income equals consumption expenditure, that's C, plus saving, that's S, plus NT, or net taxes. Then you have to switch the terms around by subtracting the terms. You get the formula that NT equals Y minus C minus S, or net taxes equals total income minus consumption expenditure and saving. The total income is 10.5 trillion, consumption expenditure is 7 trillion, saving is the flow into the financial markets, that's flow V, and that equals 1.5 trillion. Put in the numbers, you get 10.5 trillion minus 7 trillion minus 1.5 trillion, that equals 2 trillion. Okay, net taxes equals 2 trillion. Last part asks to calculate the GDP. The total income equals total expenditure, which equals the GDP, so GDP equals 10.5 trillion. There's no math that you need to do, it's the same thing. Question 2 states to use the following information to work the problems. The national accounts of Parchment Paradise are kept on, you guessed it, parchment. A fire destroys the statistics office. The accounts are now incomplete, but they contain the following data. And I won't read all these numbers, but the numbers are given there. The question then asks to calculate GDP using the expenditure approach and depreciation. Well, for the expenditure approach, GDP equals the sum of consumption expenditure, investment, government expenditure on goods and services, and net exports. Unfortunately, all these data were saved from the fire. Whew, close one. So GDP equals C plus I plus G plus NX. Put in the numbers. Get $3,000. For the income approach, GDP equals the sum of wages plus interest, rent, and profit plus indirect taxes less subsidies plus depreciation. The value of the income approach GDP survived the fire, and that's given as $2,900. And the sum of all those other numbers then is 2,000 plus 500 plus 100 equals $2,600. Depreciation equals the GDP minus the whole series of items, minus the wages, plus interest, rent, and profit, plus indirect taxes, less subsidies. That's on as the page notes. So depreciation equals 2,900 minus 2,600, or $300. For the income approach, GDP equals the sum of wages plus interest, rent, and profit, plus indirect taxes, less subsidies, plus depreciation. The value of the income approach, GDP, survived the fire and is $2,900. So that's given in the question. Then the other items are the sum of wages, plus interest, rent, and profit, plus indirect taxes, less subsidies, those following numbers, and it comes out to $2,600. Depreciation equals the GDP minus all those items, wages plus interest, rent, and profit plus indirect taxes, less subsidies. That's noted on page 120 of your textbook. So depreciation equals 2,900 minus 2,600, or $300. Question 3, calculate net domestic product at factor cost, the statistical discrepancy, and GNP. Net domestic product at factor cost equals the sum of wages, interest, rent, and profit. Once again, all these data were fortunately saved from the fire, so net domestic product at factor cost equals 2,000 plus 500, or $2,500. The statistical discrepancy equals GDP from the expenditure approach, that's $3,000, and that's from problem number 2, minus GDP from the income approach, that's $2,900. Subtract the two, 3,000 minus 2,900, and you get $100. GNP equals GDP plus net factor income from abroad. From problem 2, GDP is 3,000. Net factor income from abroad is $50. So GNP equals $3,000 plus $50, or $3,050. For problems 4 to 6, information is given. An economy produces only fun and food. The table shows the prices and quantities of fun and food produced in 2009 and 2010. The base year is 2009. Question 4 states, calculate nominal GDP in 2009 and 2010. The nominal GDP in 2009 is equal to, and you use the quantity here of 40 units of fun times the price of $2, plus $60, that quantity, and $3 as the price, and the total comes out to $260. Nominal GDP in 2010 is equal to the quantities and prices in that year, so that's going to be 35 times $3 and 65 times $2, which is $235. For question 5, calculate the percentage increase in production in 2010. The percentage increase in production is equal to the percentage increase in real GDP. In the base year, we already calculated that real GDP equals nominal GDP, so real GDP in 2009 is $260. Then you use the prices from 2009. Real GDP in 2009 is $260, and real GDP in 2010 is $265. Then using 2009 prices, real GDP grew. That is 265 minus 260 divided by 260 times 100, or 1.9%. So what's the percentage difference? 1.9%. Question 6, if potential GDP was $270 in 2009 and it grew by 1% in 2010, in which phase of the business cycle is the economy? Explain. Well, between 2009 and 2010, real GDP grew, so the economy is in the expansion phase of the business cycle. Information for problems 7 to 9. The headline reads, higher prices pushed up consumer spending for June. The Commerce Department reported that retail sales increased 0.8% in June, but net exports fell 0.3% in the second quarter of 2009, and inventories held by businesses fell by 1.1% in June, while sales at all levels of production were up 0.9%. Question 7. Which component of GDP changed because retail sales increased? Which component of GDP changed because inventories held by businesses fell? The increase in retail sales means that consumption expenditure on goods and services increased. The decrease in inventories held by businesses means that investment decreased. For question 8, explain the effect of the fall in net exports on GDP. Because net exports is part of GDP, that's the NX part of GDP, the fall in net exports means that GDP decreases. Last question, number 9. Does the statement that sales at all levels of production were up 0.9% mean that GDP increased by 9%? Explain your answer. Well, the statement sales at all levels of production were up by 0.9% is obscure. That is, it's not clear. If sales at all levels of production includes final goods and intermediate goods, then GDP is not up 0.9%. In this case, GDP is up by less than 0.9% because some components of GDP, like investment and net exports, fell. I hope that helps answer those questions in that chapter checkpoint. If you have any other questions, please let me know. Thanks very much.